Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us begin solving this step by step. Determine X moles of CO2 released from the hexacarboxylic cyclohexanone compound upon heating. The starting material is a cyclohexanone with 6 carboxylic acid groups, 2 at C2, geminal, 2 at C6, geminal, and 2 at C4, geminal. When heated, malonic acid type, geminal dicarboxylic acid, groups undergo decarboxylation. Each pair of geminal diacid groups on a carbon can lose one CO2 via malonic ester type decarboxylation, but we must also consider beta-keto acid decarboxylation. Let's analyze each position. C2, alpha-2 ketone has 2 CO groups. The carbon is a malonic acid derivative and a beta-keto acid. Beta-keto acid decarboxylation removes one CO2. Then the remaining GEM-CO, now a single CO on alpha carbon, or it could further decarboxylate as malonic type. Actually, with 2 CO groups at C2, alpha to C is equal to O, both can decarboxylate, first as beta-keto acid, 1 CO2, then as another beta-keto acid after the first loss, 1 CO2. So 2 CO2 from C2. C6, alpha-2 ketone on other side same situation, 2 CO2. C4, not alpha-2 ketone has 2 CO groups, malonic acid type. Malonic decarboxylation gives 1 CO2. Total X is equal to 2 plus 1 equals 5 moles of CO2. Wait, let me reconsider. The structure shows C1 has the ketone, C2 has HO to C and CO2H, to CO, C3 is a CH2, C4 has HO to C and CO2H, C5 is CH2, C6 has HO to C and CO2H. Actually rereading, the ring is cyclohexanone with GEMDiCO at 3 positions. Positions alpha-2 ketone, C2 and C6 each is a beta-keto malonic acid, can lose 2 CO2 each. Both CO groups decarboxylate because after first loss, the remaining CO is still beta-2 keto. So 2 plus 2 equals 4 CO2 from alpha positions. Position C4, beta-2 ketone, not alpha malonic type, loses 1 CO2. Total X is equal to 4 plus 1 equals 5. Moving on to the next step. Determine Y number of beta-keto acids, including stereoisomers, that give phenylestone, PHCH to COCH3, upon heating. The product is PHCH2, CO-CH3, 1, phenylpropan 2-1. Beta-keto acids lose CO2 upon heating, RCOCH, R, QR, CO-CH2R plus CO2. Possible beta-keto acids that give PHCH to COCH3. 1. PHCH2, CO-CH2, CO, 4. Phenyl, 3. Oxobutanoic acid decarboxylation gives PHCH to COCH3. No stereocenters. 1 compound. 2. PHCH, decarboxylation from other side, CO-CH3. I. PHCH, CO-CH3, 2-methyl, 3. OXO, 3. Phenylpropanoic acid. No PHC, CO-H, CO-CH3. This has a stereocenter at the alpha carbon. Gives 2 stereoisomers, R and S. So 2 compounds. Total Y is equal to 1 plus 2 equals 3. And for the final step, X plus Y is equal to 5 plus 3 equals 8. Therefore, the correct answer is 8. Therefore, the correct answer is 8.